Hello grade 9 students, welcome to another virtual class. I am Miss Madhu Vadke. We are in chapter 4, linear equations in two variables. And we are learning how to extract linear equations in two variables from word problems of exercise 4.3 and then represent these equations on the graph. In today's video lesson, we will continue with the same. We have solved first 5 questions of this exercise. So let's continue from the 6th question. If the work done by a body on application of a constant force is directly proportional to the distance travelled by the body, express this in the form of an equation in two variables and draw the graph of the same by taking the constant force as 5 units. Also read from the graph the work done when the distance travelled by the body is 2 units and 0 units. We have studied in physics that whenever force is applied, it causes displacement of the object. You have studied in motion chapter the meaning of word displacement. It is the change in the position of the object. And whenever an object moves, we can say that work is done. Let's represent force applied with capital F. And we know that displacement is denoted by small s. Let's denote work done by W. So we can say that work is done when a force is applied on the object and this results in displacement of that object. This implies that work done is proportional to force and work done is also proportional to the displacement. We can combine these two expressions and write it as work equal to F into S. This is the definition of work and the expression for work that you are going to study later in physics. So work done is given by the product of force and displacement. Now in this question, the displacement is given as distance travelled and there is a constant force acting on the object which is given by 5 units. So we can replace in this expression force with 5. So we have work equal to 5 times S, where S in this question denotes distance travelled. In the actual definition of work done, this S represents displacement. But to keep this question simple, the displacement is considered as distance travelled. Can you guess under what condition will the distance travelled be same as displacement? When an object is travelling along a straight path and in the same direction. So to keep the question simple, the S over here denotes distance travelled. So we have work done equal to 5 times distance covered. Let work done be denoted by Y and the distance covered be denoted by X. Then this equation can be rewritten as Y equal to 5x. Now to represent this equation on the graph, let's find the solution points. For that we need to draw a table. Let's take x as 4, then y will be 20. So the solution point will be 4, 20. If you take x as 5, y will be 25 and the solution point will be 5, 25. Similarly, the next point will be 6 and 30. Since x represents distance travelled, we cannot have negative values, and that is the reason we have chosen only positive numbers here. Similarly, Y represents work done. Now work done can be negative because the actual definition of work done is force into displacement, and displacement can be negative. However, according to the question, this work done depends on the distance travelled. So, in this case, work done will not be negative. So, we need to show only the first quadrant to plot these points. Mark the x-axis x dash x and the y-axis as y, y dash. On the x-axis, we represent the distance covered, and on the y-axis, we represent work done. Since the numbers for y-axis are multiples of 5, we can choose a suitable scale and take 1 centimeter on the graph as 5 units for work done. Let's write down the scale for x-axis and y-axis. On x-axis, 1 centimeter represents 1 unit of distance. Since the question is not giving a specific unit for the distance travelled, we will write it in this manner. Similarly, on y-axis, 1 centimeter is equal to 5 units of work done. Here is a table of solution that we need to plot on the graph. So the first point is 4, 20, which is here. Second point is 5, 25, which is over here. And the third point is 6, 30, which is here. Now join these points using a ruler. Since the x coordinate and the y coordinate cannot take negative values, we will not extend this graph beyond the first quadrant. Don't forget to write the corresponding equation. This line represents the equation y equal to 5 times x. Now we have to read from the graph work done when the displacement is 2 units and when the displacement is 0 units. That means we have to find y when x is equal to 2 units. So we move from the origin along the x-axis by 2 units, so we reach here. From here, we have to move parallel to the y-axis so that we reach a point on the line representing this equation. From this point, we move parallel to the x-axis to reach a point on the y-axis. So this point is at a distance of 10 units from the origin on the y-axis. That means the y-coordinate of this point is 10. So the coordinates of this point on the line are 2, 10. So when x is equal to 2 units, work done is the y-coordinate, which is equal to 10 units. Work done when x is 0 will be 0 because this graph passes through the origin. So when x is 0, y is also 0. Similarly, you can read from the graph work done at any given distance. So let's say if I want to find out work done when x is equal to 7, then from the graph we have to find the corresponding value of y when x is equal to 7, which is 35. Question number 7. Yamini and Fatima, 2 students of class 9 of a school, together contributed Rs 100 towards the Prime Minister's Relief Fund to help the earthquake victims. Write a linear equation which satisfies this data. You may take their contributions as rupees X and rupees Y and draw the graph of same. So according to the question, we can take contribution of Yamini as rupees X and contribution of Fatima as rupees Y. The total contribution is rupees 100. That means the sum of the money X plus Y will be equal to 100. So this is the equation that we need to represent on the graph. Let's find the solution points. We can write this equation as Y in terms of X. So Y will be equal to 100 minus X. Let's choose values of X as multiples of 10 or 20. So let's say X is 20, 40, 60. So the corresponding value of Y will be 80, 60, 40. So the points are 20, 80, 40, 60 and 60, 40. In this equation, X and Y represents money, which cannot be negative. Hence, we have chosen positive values for X and Y. So we need only the first quadrant to represent these points. Label your X and Y axis accordingly. On X axis, we represent Yamini's contribution in rupees. And on the Y axis, we represent Fatima's contribution in rupees. Let's write down the scale. On X axis, we are representing 1 centimeter as 10 rupees. And on the Y axis also, we are representing 1 centimeter as 10 rupees. So the first point, 20, 80 is over here. The second point, 40, 60 is over here. The third point, 60, 40 is over here. Now join these points using a ruler and label the line with the corresponding equation X plus Y equal to 100. For this particular situation given in the word problem, we are representing only the positive values of X and Y, which means this line will remain in the first quadrant. Hence, we do not put the arrows at the ends of the line for this question. Now the equation that we have is X plus Y equal to 100. If I write this equation as Y in terms of X, I get Y equal to minus X plus 100. Then the constant in this equation represents the distance of the point from the origin where the graph cuts the Y axis. So you can see on the graph this is 100, which is equal to the constant in this equation. Similarly, if I represent the same equation as X in terms of Y, it will be X equal to minus Y plus 100. Then this constant represents the distance from the origin of the point where the graph cuts the x-axis. These numbers are called as intercepts. So this is the y-intercept and this is the x-intercept. With this, we come to the end of this video lesson. Your assignment for today is to draw the graphs done in today's video lesson neatly in your notebook. See you in the next class. Until then, goodbye.